Hi, I am George Cooper, and the session we're doing here is Beyond the Calc Dim, some advanced calculation techniques. And this is kind of a potpourri of different things. We're going to go through a case study of an application that we built at the Gap. I work for the Gap. Of an application that we built for the Gap to do an incremental variance for a distribution supply center, which has a lot of different factors, and we'll go into the details. Then, and this is probably the most interesting part of the presentation, we're going to talk about hybrid on-prem. Everybody's heard here an awful lot about, just 1 second, please. Unfortunately, we had a technical difficulty. My computer crashed just as I got up here, and which is relatively inconvenient. So I'm trying to get it rebooted here at this point. And so I'm just going to be talking without slides for maybe 5 or 10 minutes before the slides come up, and hopefully it'll boot. Anyway, but then we're going to be talking about on-prem hybrid. And we converted some BSO cubes to on-prem hybrid. And this wasn't in the original abstract for the presentation, but I think there's some really, really interesting things here, and we were able to get around a lot of the restrictions that are in 11.124 hybrid at the Gap. And I think there's some really good little pieces of information in that section. After that, we're going to be talking, I'm going to kind of shift gears there and get really theoretical on you, and I'm going to go through some common calculation techniques. For people who are really Essbase experts, some of this may be review, but we have a lot of people working on a lot of applications at the Gap, and even people who've done this a lot, they forget this sometimes or don't have the theoretical background on some of these operations. So we're going to go through that. Then finally, time permitting, we have some techniques to load members at upper levels but still have everything stored at level 0, and some iterative calcs. And hopefully I have a presentation. Oh, that's good. Okay. Hopefully this will start in a second. I would like to introduce up here one of my compatriots, Nagendra, who's a technical manager at the Gap, and he's worked on a lot of the projects, and he's going to help me out here.
Hey, Nagendra Simakurti. I work in Gap in the Essbase team. And hang out with George here.
The mic, sir. The mic. There we go.
So I'll hang out with George here, trying to pitch in wherever I can.
You have to speak into the mic.
So I just want to pitch in some of the slides where we actually build this a report which is out of Dodeca.
Use your other hand.
Both hands, okay? Cool. All we're trying to build here was an interesting report, which is not a usual use case you get in many of the Essbase shops. Like we got it, and we built it, and we're going to show you how we achieved the trick on that.
Right, and that's the first part. That's the use case for this distribution center thing. So I'm going to do this from memory, because I have an old computer, and it takes an insane amount of time to boot up the computer, and it crashed. So it's still spinning. I really apologize for that, but hopefully maybe 5 minutes it'll be done. But let's start, and then we can catch up with the slides. Ooh, I got my desktop. We have a very large, Gap has what, 3,500 stores or some enormous number of stores, and so we have a very large distribution organization, right? And this is a And the distribution organization is a standard thing where you got big warehouses, you got product coming in, it's in cartons, and some of the stuff is like 30 pans per carton, some of it's 5 pans per carton, and you have various functions that go along the way in order to get it into the distribution center and out to the stores. You have online business where you don't ship it in bulk, you ship individual things. Different functions have different skill sets and are affected by volume differently. So each distribution center may have like 300 or 150, 200, maybe 300 different combinations of drivers that affect the cost. And here we are. I'm going to leave this thing so it finishes starting up everything here for a second. So, in general, what you have is each center will have a number of functions, right? And then like picking or putting things on a truck or taking things off a truck. And then each function has a number of drivers, like for every unit that's being processed, how much time does it take for that function, right? How many units can be processed at once for that function? How much do you pay the people who are doing that function? And so on and so forth. And we are almost. That, by the way, is a view of Yosemite Valley for people who aren't from California. One of my favorite spots in the world. And we are almost there. Okay. Okay, so that was the problem. Now, if you're managing this, right, and let's say somebody says, well, my supply center, the cost of the supply center went up by $50,000 last month. What happened? How do you know what happened? You have like somewhere in the vicinity of 150 different things that go into this. How do you know which one actually resulted in or which set of things resulted in the increase of cost? This is a common problem across many businesses, right? Well, the answer is, and since this is going to start right now, I'm going to wait till the slide comes up. And here we are. Okay, the opening slide. That's me, Gap Inc. We'll go through all that. Common business problem, I just got done with that. Well, here's a sample report. This is what we wanted to get at. We wanted to get at a situation where you could have the starting forecast or the starting actuals, have then a set of incremental variances that go down, and then wind up with an ending forecast. And if you took the difference between that bottom line and the top line, you have the total variance between the forecasts. But each line in the middle says how that particular factor affected either decrease the cost or increase the cost. And this is what we were after. But again, there's about 150 lines in that report, and I only showed you 6. The solution, and I don't know whether anyone here has done this at all at your business, the solution was just brute force. There's no rocket science here. It just pounded out. And that means that I take the starting forecast, put it somewhere, change the first factor, recompute the total expense, capture the variance, store that in a member, and then go on to the next one. And then the next one, and then the next one, till you iterate through all 150. And that way, for each one where you started out with, the variance for that run will be the incremental cost for that one factor you changed. Anybody follow that? Anybody not follow that? Okay. You know, actually, I asked if everybody followed it, and everybody didn't follow it, and I got the same response. So anyway, we'll keep on going. But there are a few challenges here, of course. Like, where do you store it? How do you manage it? How do you do this without a whole bunch of hard code? For God, you can imagine the amount of hard code. You can imagine you could do this in a 10,000 line calc script, but then somebody's got to maintain it. How do you get it to run fast enough? This was a big deal. And what software do you use? The business actually had a consulting firm come in and do this, and they said that they couldn't do it in Excel, or it couldn't be done in Excel, excuse me, in Essbase, and they did an Excel model for it, which is what we were replacing. But we kind of put our heads together and we found a way to do it. So let me give you the highlights here, because this is an approach. No, I don't want Java updated. This is an approach, so we're not going to go into all the really nitty-gritty, but we're going to show you how we went about it. First thing we did is there are two dimensions that vary: the function in the facility and the account, which would be number of units, the pay rate, and so on and so forth. But we made one structure in the accounts dimension which had all of the individual variances. So it had all 150 lines, and if you can see it, that's right over here. So here are the individual ones, and they add up into subtotals, which then add up into a total variance. So this made reporting easy. We put something in the accounts dimension with all 150 of them. The way we managed without hard code is that we then built a spreadsheet. And the spreadsheet would have the factor to change right over here, the function that was going to be changed for that line, so the account and the function, and then this was the line we were going to put the result in, right? So as functions were added or subtracted, all you had to do was change the spreadsheet. So we didn't have to hard code anything in the calc scripts. Entirely driven off the spreadsheet. So you had about 150 lines here. Then we wrote a whole bunch of parameterized calc scripts. One that would do an initialization, which would take the starting forecast and bring it over to a working member. Then a set of calculations, one that would compute the expense for all the factors, and then compute the variance and stick it in the right bucket. And then it would just execute those two calcs here in the middle. It would execute them, like I said, 150 times. Then you would get to the end, and it would take the ending from the working, it would put it over to a bucket. We had it structured so you could run a comparison against like 5 other scenarios, prior actuals, prior the budget, and so on and so forth. So that's the general approach. Stick it in a spreadsheet to control it, write a calc script to do it, and write the calc script so it ran really fast. Okay? That makes sense, everyone? To get it to run quickly, and here's where a couple pieces of advice. One, if you have a calc script that you really need to run quickly for any particular reason, in other words, 5 seconds isn't good enough, 8 seconds isn't good enough. We're talking half second, at the max, or 3/4 of a second. You should probably think about making a database that has the dimensionality that will most suit that calculation. With an X-write, you can always move it back and forth, and many people have planning here. And planning will give you different plan types. So structure the database so it will be very, very efficient for that one thing. And then when it does the result, you can always do an X-write back to the main GL database with the variance. And that way, the calc that you're running will be very quick. Okay? What we did, we marked everything involved in the calculation dense. So everything was pulled into the block. And even though we had to run through a number of calculations in it, everything was dense, so everything went boom, because there was very little I/O. We took the time dimension and made that sparse, because you might select different time periods, right? And it didn't take all that much time to pull in 12 blocks, so you were doing it for 12 months. But by having all the business logic all dense in one block, it could run very, very fast. Where possible, and we haven't really gone 100% on this yet, where possible, you want to combine calc scripts on the client side. Instead of running 300 calls to the server, if you can kind of batch them up, run 15 calc scripts at a time or 20 calc scripts at a time, and then do the next one, it would cut down on I/O. We haven't done that yet. We're still actually doing 150 different sends to this server. But we just haven't gone around to it. You don't ag anything, obviously, till the end. No point in agging everything, right? We're trying to work this out for a center, so you don't ag it till the very, very end. And because ags, take the most time. So we got it to run in less than a second. per calc. So all 150 or so only take a little over 2 minutes. Now there is the init and the ag and the in, but so when a user wants to calculate their what they call a recon report for a facility, the whole thing runs in 3.5 minutes or something, which is well within the guidelines that we told them they would do. And the nice thing is you can also select and do the entire organization. That takes a little longer, but it's the same principle. It just loops through everything. And by doing that, you gain some efficiencies, and we can do the entire organization in about 8 minutes.
And don't discount the script. It is a decent script, which even though it runs in in a couple of milliseconds, it has a lot of stuff in it actually. It does a decent number of things on that.
Yeah, especially when we got into allocations here. I won't go into the gory details, but that was nightmarish. But we'll get into allocations a little later. Okay, everybody follow? Yeah, Scott. It's really not very big because we took time. If we made time sparse, then the block size would have been huge, but we didn't make time sparse. So the block sizes, I don't have it top of my head, but it's like 10K, 20K. It's not very. That also helps speed, by the way. Small block sizes, less I/O, less pulling in and out. So.
And moreover, we moved out from the main cube, right? We are on the subcube here. So this is more a subcube of the major finance cube. So overall, the cube block size should be small.
Okay, so how do you run this? Anybody have any thoughts in the audience of how you would do this? If you were charged, remember, these are parameterized calcs. You pull the values off the spreadsheet, stick them into the calc script for every iteration. So you've got to run, runtime calcs. Anybody have any thoughts on if you were going to build this, what software you would use to build it? Anyone in the audience? Yeah.
You may run a macro in Excel where we just read all the VBA code and create your calcs.
Bingo. And in fact, that's what we did on our POC. Now, we could do that even before SmartView supported parameterized calcs because we had a thing using the old Essbase API to pull the calc script over the server and do a text substitution. The Essbase API isn't supported anymore, so that would make it more difficult. But runtime prompts are in SmartView, so you could do this now with the SmartView API. It wasn't supported when we did the POC, by the way. That's a new addition, supporting the runtime calcs in SmartView. You could also do it with Excel. You could do a batch script in Excel and call the parameterized calcs from Excel, but that's a little harder to orchestrate. We decided that we would go with somebody you've probably seen a few presentations on here. We decided we would go with Dodeca for it because it had a lot of advantages for us. One, we now had 2 databases, and that confuses users a lot unless you make it transparent to them. So why is all of a sudden there an echo? Anyway, so the nice, this has not been the most technically smooth presentation I've ever done. The nice thing, we have 2 databases now. The nice thing about Dodeca, it's a unified front end. So the users can go into forms to send information of one type, and send information of another type, and they don't have to know what database it's connecting to. All they know is they have a form to input rates, they have a form to input this, and they don't need to know, what the database are going to. So the Dodeca front end allowed us to insulate the user from the fact there was multiple databases. It also, and this is where Nagendra is going to talk a little bit, it also has an incredible amount of automation capability behind it. As some people said, Dodeca makes very complicated things easy, but makes simple things kind of complicated sometimes, because it does have such a rich layer of features that just doing a simple report with a drop-down may take you a little bit. But doing something like this was Snap City with the automation behind in Dodeca. So at this point, I am going to hand it over to Nagendra for a second.
Again, so the very reason we went to Dodeca is one, we can trigger our calcs. The very reason we went to Dodeca was, one, we could trigger our calcs, we could do our reports, and the same place they're all doing the forecast. And it's all one centralized here, right? For our trick, all we need is, we want a place wherein we can trigger our calcs 150 times, passing different parameters, giving the flexibility for the users to drive theirs by for the different DCs and for different scenarios. So this is the user interface, which is actually the driver for those calcs, which would actually run the calcs, substituting the values from those sheets and reading each line and passing the parameters to the calc. But the real logic or the real architecture behind the sheet is over here. Okay, good. So the user's experience is the previous slide, right? So behind the scene, what we're trying to do here is we kind of populated the combinations where the drivers are loaded. So the column A is the account, and the column B is the functions where all those drivers are loaded. So we take each line, and column C is where we are actually storing the variance after the run of that run, of the cycle, right? And column D is more about how do you want to control it, whether you want to run or you don't want to run. So basically, what this form does is, on the top, it has a section to prepare the scenario. So it has a section to say, okay, what is my start and what is my end? Do I want to actualize any of the periods post I run this? The top section helps the user to select and prepare the scenario. And here, the section which is having these columns, in Dodeca they call them tokens. What they try to do is, they read this sheet and replace these tokens into the calculation script. And next step is you read those tokens, put it in the calculation script, which is built in Dodeca. Then you submit to the Essbase server. The only catch here is we see more a latency in the network than the actual calc time, because we are trying to go to and fro like 150 times each time it reads each line on the sheet. And finally, it would update the status of the calc. It has been run. And then continue to read the next line and and again substitute the variables, calculate the variance, and plug the variance into the member in column C. So that's how we achieved this ability to trigger the calcs 150 times. And it's low maintenance for the reason if I had to add a new function, I just need to add a row here and flag it to Y, so it transfers the next calc. That's what it is.
And so that's Dodeca. We've had very good receptance from the business partners on Dodeca. They like the tool. They like the fact they don't have to know where it's going or how to operate it. And again, the automation here is extremely rich. This is just a sample of the entirely menu-driven automation. You pick things from a menu. Stuff over here is, let me see if I got the thing. These are adding tokens. They pull it out of the drop-downs. These are execute procedures. This is, we can create audit sheets of all the substitutions it does. And this is all menu-driven with properties down in here. Where is my mouse? There it is. Menu-driven with properties. And so you never write a line of code in this.
These are all out-of-the-box wizards. We just need to fill in and use them for your purpose.
That ends that. And I just hit the thing. Any questions? Yeah. Pure Essbase. Gap, I didn't mention that, sorry. Gap is a pure Essbase shop at the moment, except for one PBCS cube. So all these cubes are pure Essbase. And that's why we're a little challenged sometimes, because historically we haven't had a centralized tool to hold your spreadsheets and your input forms. People have held them on department drives, Excel sheets, and so on. Yeah?
How do you get the data from one sheet to the other sheet?
we used X-writes, and I really recommend using X-writes rather than X-refs. Anybody know? We're going to talk about a lot about this in the remainder of the presentation. Why should you use an X-write? In other words, push it from the cube over to your target rather than an X-ref, which does the pull. Pardon me? Block creation. Bingo. You do an X-ref, and you may have a block on the source side that doesn't exist on the target. The X-ref, if you sloop through on the target side, it's never going to hit a block there, so it's never going to do an X-ref. Having the block doing the X-write, you know you're going to write everything that exists in the source cube because you're cycling through it, right? And the X-write will create a block if it needs to. So, transferring data between cubes, if you have any choice about it, use an X-write. Don't use an X-ref. Oh, sure, but last one, because I got a lot of slides.
Why do you not use export and import of the data?
Because we want this to all happen in the dodecaform on something that is not run by Excel or anything like that, and so we want to use formulas.
Real time, you just push the data with extracts, whereas the other guy we have to see cube downtime.
Okay, now for the exciting thing. This was added to the presentation. It's not in the abstract. We converted some cubes to on-prem, and I am actually kind of excited about going over this because we found a way around some of the limitations. Now, you know, you've heard a lot about hybrid in the cloud. It's wonderful. All these things I had to work around on-prem don't exist. But how many people are going to go to the cloud in the next month? I don't see a lot of hands. A couple, okay. And certainly the gap we're seriously looking at it at some point in the future, certainly, right? But right now we're on-prem, huge on-prem. So, how many people here are familiar with hybrid? All right, gosh, that's great. So I'm going to go over this quick. You know, you enable hybrid just by putting a config file setting in, right? Turn on hybrid. Theoretically, nothing else. Well, not quite. You mark your sparse hierarchies dynamic, right? And then it'll do them dynamically. If you don't mark them dynamic, it's just like BSO. Is everybody aware that Calc scripts, at least on on-prem 11.124, they work exactly like they did before? There's no change. Any functions, anything you want to do in a Calc script, you can still do in a Calc script. There's no change. Dynamic members, however, on the on-prem, only certain functions are supported. We can get around that, but no cross-dims. That's a killer, especially for currency conversion and stuff like that. No cross-dims. If a formula isn't supported, what happens? Does it fail, or does it do a really thing worse than failing, worse than death? It goes back to the BSO regular dynamic aggregation engine. Ever tried to add up a 10,000 member hierarchy that was all dynamic calc members? Yeah, maybe 3 days, then it'll come back. So, but you don't have to go all the way either, and we didn't at the gap because we left 2 of the dimensions in these cubes stored for various calculation reasons. We had to, we were able to get intelligent calc to work on this, but in order to do that, we had to, that's a whole nother presentation in and of itself, but we left 2 of the dimensions stored, okay? So how did it work? In a short term, awesome. The ASO aggregation engine is fantastic. In the stored hierarchies, the ones we marked dynamic, the retrievals were only slightly slower. They were slower. Obviously, if you got a block out there, it's going to be really fast. But they weren't that much slower. But that wasn't where it shines. I don't know about you, but most of our users report off of alternate hierarchies. The main hierarchies come from the GL. Some reports are done off it, but most reports are done off alternate hierarchies. And these are usually dynamic because when somebody adds them, they don't want to reaggregate the cube, right? So these now fly because the old dynamic alternate hierarchies use the old BSO engine, right? Now your alternate hierarchies use the ASO engine. Awesome difference in speed. We had retrievals go 3 times faster, 5 times faster, just because the alternate hierarchies were dynamic rather than stored. So this is, even if you left all the primary ones stored, I would switch it to hybrid just for the alternate hierarchies. Even if you left all the primary ones stored. It's that much faster doing that. Okay, most calculations were supported in 11.124, and we didn't have much trouble getting around them. The ones that weren't, there were a few. I can't even remember what they were. But the real killer is they don't support cross-dimensional. Everybody's aware of that here, right? Can't put a cross-dimensional in a formula. Kills it. So how do you do that? Well, there's a way around it. You can use a sum range function that is supported, which works like a cross dim. Everybody see that formula? Sum range, rate amount, list, template input. That is exactly the same as rate amount / template input. No difference. In fact, the performance, if anything, is a little better even in straight BSO. So you can replace a single cross dim with that formula, and that is supported in hybrid. Now, that doesn't entirely solve the problem here, does it? Because you probably don't have one cross dim, and you can't embed these together. So what do? Anybody have an idea? This works. How are you going to make it work on 4 cross dims? Anybody have a thought? Pardon me? Yes, later on. I'll show you a slide on that. Now remember, this is all dynamic because you don't have any problem using cross dims in the calc scripts. I mean, it's just straight BSO in the calc scripts. This is all dynamic members. Okay, the way you do it is you chain them. You can you can make one cross dim, and then you can have another member which refers to that cross dim. So you build a chain. If you can't embed one sum range with another, but you can reference another member that has a sum range. So we successfully chained up to 6 to have a 6-place cross-dimensional. Do I recommend that? No, and we'll go into that in a second. But another thing, and that's this last one down here. Some of our cubes have up to 30 alternate FX conversions, but there's 3 or 4 people use all the time. The other 25 are for one-off reports and one-off things. So we made sure that the FX conversions, they use it all the time. We now store them. The cubes are way smaller. So we embed those in the calc script, and you can do anything you want to in the calc script. So we calculate the ones that people use all the time and use this technique only for the more one-offs. But we still have like 25 of those, and it's impractical to store all 25. Okay? All right, let's look at this. So we have rate temp input, and that equals sum rate amount list template input. And then that goes down to rate area, sum range, rate temp input, list that one, and then rate product, and that goes down. You get the picture here, right? You can chain them down, and it works. And it is not as slow as you think. I just want to check the time. Yeah. However, it is slow because these are subqueries. Each one is a subquery. So the way to get around this, we took some small non-aggregating dimensions and changed the calc script so it would duplicate the FX rates in all the members of these a couple small dimensions. Right, so we had a dimension which was like format. People didn't use it very much. It only had 10 members in it, so we just wrote the calc script so it would duplicate the FX rates in all 10 members. That way I didn't have to have a cross dim in that dimension. I was able to do this for 2 dimensions. So that brought it down from 6 to 4. Now the first thought is, why would you bother? You only got rid of 2. Anybody know why I bothered? And you can read the slide and you can answer my question if you can see it. Why did I bother? It's geometric. They're all subqueries, right? So it takes time to do X, and then you do another one, it takes twice that, and you do another one, it takes twice that. So by getting rid of going from 6 to 4, it had a 75% increase in performance. So absolutely. If I could go down to 3, I would, but there's no more small dimensions left, so I'm stuck. Okay, but still the performance isn't as bad as you would think. Some other notes. Okay, everybody follow that? this was really cool. I mean, when we got this to work, it was like, eureka, oh my God. We can now convert these cubes with almost no impact on the users. First thing, it's okay to leave some dimensions stored. It works fine, because remember, it's the alternate hierarchies that are the wonderful thing anyway, right? So we have 2 dimensions we left stored because of some restrictions on the way we were doing intelligent calc. That's a whole nother presentation. But that's perfectly fine to leave some stored. This was interesting. You think about marking all your hierarchies dynamic. We found that in dense dimensions, this was horrid. Because I think what's happening, and I don't know the internal architecture, I think it goes in, ASO has two calculators. It has their stored engine, which is really fast. And when you mark a hierarchy dynamic in ASO, it does it at report time. It doesn't do it with the stored engine. I think it's doing the dense hierarchies with the dynamic engine because it was super slow. We had a hierarchy with about 100 members in the accounts dimension, which was dynamic, and it was just horrible in speed. So mark your dense dimensions, dense hierarchies stored whenever you can. It's just way faster. A few other things. Got to set your ASO cache. I mean, this is ASO. And so if you do a lot of calculations, you're going to have to set your ASO cache. That can be set in Excel. There's nothing in EAS for it, but you can set it in Excel. If you have a lot of formulas, you're going to have to increase your max formula cache size in ASO. Everybody familiar with that from your ASO cubes? Anybody ever set that in your ASO cubes? We have a lot of formulas embedded in them, so you often have to increase the max formula cache size. You may have to do that on your cubes too. It applies to your hybrid cube just like it does ASO. This was interesting. At prior says it was supported. Well, it's supported with an asterisk. It's supported if the formula is bottoms up. Everybody know what that is? Okay. Essbase has 2 kinds of calculations, a bottoms up and a tops down when you're doing a sparse calculation. Bottoms up means it looks at the data that exists and just operates on that very fast. Tops down means, I may not get the right answer if I just look at the blocks that exist, so I'm going to look at every possible combination and see whether there's an answer. How fast do you think that is? The difference can be incredible. If you have a report script going against an ASO database, and it can run bottoms up because there isn't a complex formula in it, it might run in 20 seconds. If there's a complex formula, it might run in 30 minutes. The difference can be enormous. Well, this does not work if it's tops down. Only works on bottom up. But the default for this function is tops down. So therefore, if you just put this in a formula, it won't stay in hybrid. You'll look in the log, you can see that it went out of hybrid. You have to give it a command in the formula, calc mode bottoms up. And that will turn off the top-down calculation, and then this formula is supported. Everybody kind of follow that? I know it's a little techie, but that's... Now, of course, you told it to be bottoms up. If the formula won't work bottoms up, in other words, if it's not a one-to-one on the blocks that exists, then that's a different matter. Then it works in hybrid, but you get the wrong answer. So you got to be careful. All right? Everybody kind of follow that? I'm going to keep moving on, but okay. Don't forget that in your hierarchy builds, you need to set everything dynamic when you update the hierarchy, because if it adds a new member, how's it going to add it? Store it. So you have to have a second pass to mark all your parents dynamic, which can be problematic if you're doing a parent-child and you don't know which ones are parents. But that's a problem for you to solve, not me here in this presentation. If you need a dimension total but don't want to store the hierarchy, stay tuned, don't leave till the end. I'll show you how to do that. Okay? But you can do it. And okay, test your formulas with members. When you test this, go down in the bottom of the hierarchy, so even if it switches out of hybrid, it's not going to take forever. You can run it, and you can look in the log. It'll tell you whether hybrid mode was enabled or hybrid mode was disabled for that query. So you can test to see whether your dynamic formulas. All right? So how did it work? I'm as thrilled about this. I've been doing Essbase for a long time. This is awesome. I mean, really. It's cubes are smaller. And even though I stored 2 dimensions, you know, again, aggregations are geometric. You take away 2 aggregations at the end, you have a huge decrease in database size, even though I still have 2 stored dimensions. So things are faster, retrievals are faster. Percent sales, a 2-pass dense member we have sometime in the view dimension. This is slower than, I can't swear here, it's being broadcast. But it's really slow in regular block storage. That formula flies in ASO. It's as fast as any other dynamic formula. So reports that had percent of sales used to be very slow for us. Now, I mean, they aren't super quick, but they aren't that slow. So I just gave a testimonial to hybrid, but I mean, it's so far we're very excited about the potential here, even on on-prem. All right? Questions? I'll be happy to answer them later on. Let me keep moving because we're going to run out. Okay, now we're switching. I said this was a potpourri. You know, we talk about a million different things here. I'm okay. Let's talk about some theory, okay? Some calc script theory. Now, moving referencing data between blocks, I'm going to concentrate a lot on missing blocks and the block creation problem. How many people here have ever written a calc script and had a block creation problem? Does that happen to anyone? Okay, yeah, I figured. All right. This seems obvious, and I'm sure many people in the room already know this, but it's worth repeating because we have a very, very good Essbase shop at the Gap, a lot of really good people, and even they forget this sometimes. Always ask the question, what blocks must exist? If there is an answer to that question, then cycle through those blocks. It's like the xwrite versus xref. For the data we're transferring, we know that everything we want to transfer exists in the source cube, so we use an xwrite rather than an xref. It's the exact same thing in a fix. If one side has to exist, cycle through that. And then put the cross dim on the other side. For instance, and this is my example here, if you want to copy total expense from prior forecast to current forecast, do not write this because the block may not exist in prior forecast. So that is a bad one. I should have had, let me see, a Ghostbuster ghost coming out of here, but that's bad. Don't do that because you'll have block creation issues all the place. Now you could say create on equation, you know, or something, but these all evaluate top down and you can just screw, you can really do bad things to your performance. So don't do that. It's an easy fix. Do this instead. You know when you're copying it, you know the prior forecast exists, you're copying it, right? So you know everything exists there. So put the cross dim on the other side. Have it cycle through and write it over to current forecast. You'll never have a block creation issue doing this. This is my favorite way, this right here is my favorite way to create blocks. Because I can create only the blocks I want all the time. Like if I didn't want to create an empty block, I could put an if in there. If the account is empty, then don't do that, right? Just skip it. So I can now, and there's no other command that'll do that. Even the new create block where you can tell it what to create, then you got to tell it to create that block even if there wasn't any data for it. This will create the block, you know, only the blocks you need. This is a wonderful technique. So, mantra, think about it. Gee, is there some place that all the blocks have to exist, and if there are, cycle through that. Okay? So I put a little green circle around that puppy. What if I'm computing the difference between 2 scenarios? Well, now, you know, now they both kind of have to exist. Well, often it's not that, because you're only working on level 0 data, it's not that hard to do 2 passes. First, go through the prior forecast, and, you know, I go there if expense is not equal to 0. By the way, this little trick here, you know, if I just said 0, it would fail on missing. So you normally have to do, is it 0 or is it missing? Well, that's wordy. So if you just add 0 to it, then you can just test for 0, because then it'll check 0 and missing. It's a nice little trick. But anyway, I just cycle through the prior forecast and just write anything. I could write a dummy account, doesn't make any difference. I just want to create the block. So this first pass just creates the block, or just ensures the block is created. Most of the time they do anyway. But if one wasn't there, it would then create the block in current forecast. And then I can fix on current forecast and do the variance, because now I know I have a block in current forecast for everyone that had an expense value. Everybody see that? Never have a block creation problem. Never, ever, ever doing this. Okay, everybody has heard. Well, you don't have cross dims on the left side. Well, that's one of those things that people say don't do, but in my experience, maybe not. Maybe it's okay. It's really only the case when you're writing the same value over and over again, and people do this sometimes, and this is my really bad example of this. Here, I'm selecting all the I descendants of income statement, but I'm only writing to expense. I'm only writing expense to expense. So here I'm cycling through. This is a dumb example, but still, it happens that you do this and you're actually just writing over and over and over again the same value. This is where it's very inefficient, so you don't want to do that, right? But other than that, and there's one more example where it's not good, but other than that, it's great. And I said it automatically creates your blocks for you. So bottom line, watch for instances where you're cycling through many members on the right side, but only one member on the left side, when only one value. One value, but going through a lot of blocks, that's not good. So I have a big X on that. All right, one last thing. The other thing that is bad. Anybody here know about calc mode block versus calc mode cell? Okay. Super important BSO concept. If it operates in block mode, that means in some rocket science in the engine that they do, they can like compute all cells at once or something. They don't care about the cell order. They optimize the cell order, and the calculation in a block is much, much faster. That's that calc mode command you saw previously for bottoms up or tops down, right? But now, rather than being on the sparse dimensions, which is where bottoms up or top down applies, it's now on the dense dimensions. And it tells you whether you're going to calculate all cells kind of at once or one by one. If you have a prior or you reference another calculation that's in the block, you can't use cell mode block, because then you'll get the wrong answer. Those things almost always default anyway to the cell mode. A cross dim on the left side will default to cell mode, so it can be much slower. But you can force it to go to block mode. Now there's two caveats here. One, in the other examples I didn't bother because I was only doing one account. Since I'm only doing one account, it's not cycling through all the accounts. So I had the formula. Did everybody see that in one of the prior ones? My formula that I was associating it with was only one account member. So you really don't need the calc mode block because you're only going to one account anyway. But when you have something like this, where you select all the descendants of income statement, and then you have a dense view dimension that is, people seen this, you have one dense member, use it for calculations where you want to cycle through all the accounts. So now I'm selecting all the income statement accounts, and I'm taking every one of those accounts and I'm writing it over to prior forecast. Everybody kind of see that, right? This will go in cell mode. This will be very slow. And there's no reason for it to be in cell mode because there's no dependencies between the accounts. I just want to write them all. Yeah? Yet one more technical difficulty. There it is, finally. All right. Anyway, here it is. Okay, yes, sorry. I'll fix that. Obviously, I'm cycling through prior forecasts. I wouldn't write back to prior forecasts. Thank you, Bill. Let me go back here. Start the slideshow. Start the slideshow. Let me see. Anybody want to buy me a new computer? All right. You put a calc mode block in there, like that. That will then force this to go into block mode, not cell mode. You'll see a dramatic increase in speed of executing this. Don't do this if there is a dependency between the accounts. If you are calculating sales and then you want to calculate a cost of sales on the previously calculated sales, that's a dependency. You can't do calc mode block on that. But if you aren't doing that, this will run much, much faster. Okay? And again, the only time you don't need that if you're only calculating one account. You really kind of need that if you're cycling through a whole bunch of members in the dense dimension. That's when you kind of need that. All right. How many people have written an allocation script? How many people thought that was a ton of fun? Oh, all right. How many people got even a little bit frustrated? Okay, let's talk about this briefly. We're not going to go huge on this, but allocation driver and target blocks. There's two, I think, this is George Cooper's theory here, is there's two kinds of allocations. One where the driver is in the block where you're sending the amounts, like sales. You want to allocate stuff to products and you're doing it by the sales in the product, right? Well, this is a simple situation, right? Because you know the blocks exist. Again, there's no block creation issue because if there wasn't a block, there wouldn't be any sales and therefore it wouldn't get any money, right? So this is the type of allocation one. Does the driver exist in the blocks you're sending it to? If that is the case, you only need to cycle through all those blocks and you can just do a regular formula, the expense equals the headquarter expense times the sales for that product divided by the total sales, right? Everybody's done that kind of formula here. But you need to determine what the total sales are. How many people have done that with a Calc Dim? Is that going to work in hybrid? Anybody say no? Let me see, somebody say no. I'll say no. Computing a total without a Calc Dim. This is a wonderful technique, by the way. And I've credited to consultant Nick Nikolakakis, who showed me how to do this in a project a long, long time ago. First, you take your total member. I put the actual total members, which are at the top of the hierarchy. This was a BSO example. But you can make them any members you want. They can be level 0 members, something you said total of all products or total of all areas, and not have it at the top of the hierarchy. First, clear it out, clear sales out. Then fix on the level zeros of those two dimensions and have this formula. Sales cross-dim total products, cross-dim total areas equals sales cross-dim total products, cross-dim total areas plus sales. Right? As that goes through all the level zeros, it's just going to keep adding and adding and adding and adding until when you're done, you have the total. And then you can use that in your allocation. And you did this all without a Calc Dim. Many, many times faster. We did an allocation system for a large health company, and we extensively use this. So then this is just the computation. You can take the expense that you have in the headquarters and multiply it by the ratio of the sales. You never did a Calc Dim, and it worked great. Okay? Everybody got that? We're almost done with this journey. Let me see how much time I got to wrap this up. 6 minutes. In the above example, blah, blah, blah. Okay, what if it doesn't exist? What if the driver's somewhere else? This happens all the time. People load a rate somewhere and you want to drive it by the rate. So it doesn't exist in your target blocks. Now the target blocks may not exist. This is where you want to use the allocate statement. I love the allocate statement. How many people here love the allocate statement? And if I see a hand, I'll be surprised. Okay. But actually the allocate statement's great. It solves a lot of problems. It creates your blocks for you. It's really a really useful thing. There's a couple things you need to know. And so I've rewritten that last allocation using the allocate statement. Same thing, it just uses the allocate. I mean, you can use it if the driver's in the block, but now it's the more general case. Couple things on allocate. Remember the mantra, what blocks exist, where does the data exist? That's what you fix on. So you fix on the blocks you're allocating from in the allocate statement. That's where you fix. You don't fix on the ones you're sending it to, you fix on the ones you're allocating from. Be sure to make this fix as restrictive as possible. Target blocks do not need to exist, and they will be created. That's why we use it. The first argument must include with Crossdims a member from every dimension you're allocating to. That's a requirement. It will fail if you don't do that. That's documented, but you need to do that. The driver does not need to be in the block. I already said that. The allocate only does one dimension. So you only, you want to go from, you want to allocate across all products. The MD allocate allows multiple dimensions, so you can allocate across all products and maybe areas. Now, if you're changing blocks, if you're going from prior forecast to current forecast, is that an allocation? Is that an extra dimension, even though you're going one block to one block? Somebody answer, please. Sorry. Yes. The answer is yes, it is an allocation. You're changing dimensions. So remember, if you're allocating to products and areas, but you're also changing scenarios, that's 3 dimensions you need in your allocate statements. Because you're changing 3 dimensions. You got to be careful. Number combinations goes geometrically. So you got to be real careful. We aren't going to go into all the syntax of the allocate statement. The documentation may be hard to read, but it's accurate. All right? Actually, we're not bad. I added the hybrid stuff because I thought that would be really useful. So 2 of the things that were on the original abstract kind of got pushed. And, oh, wait a minute, 2 other things. Intelligent calc and aggregations. I talked about this in another case scope. When you're doing an ag, let me see if I can back up and do this again. Oh, shoot, I picked in show. My apologies. In this situation, how much time do I got? I got about 2 or 3 minutes, okay. Fix on specific, so you fix on specific members, maybe runtime calcs or something, right? And you do some business calculations. So you've only modified a few blocks in the database. Set update calc off when you do that. Everybody sets update calc off, so that won't be a problem. But then, set update calc on, do clear update status after, and do your calc dim. And make sure the first dimension is dense. This will then calculate those, do the ags for only those blocks, and mark them all clean. There is no downside to this. You will not have a problem with concurrency. We use it everywhere. And your ag times go way, way down because you're only agging the blocks you changed. The reason why you don't have any concurrency problems is the first part of it, you set update calc off. So you always did those blocks, regardless of whether they were clean or dirty. It's only the ag that you turn them back on again. Turn update calc on. No downside to this, really. You really got to watch it when you're doing sparse formulas in a sparse dimension and adding things because the rules on whether it goes top down or bottom up are really weird. And you can read about them. There's that member order and everything. And as we talked about, bottoms up is way faster. So if you can get away with bottoms up, turn it on yourself by putting that in the formula. The 2 things I skipped, I put them in the presentation. I'm out of time. I put them in the presentation so you can read about them. We have a neat thing where we allow people to send data to any level in a hierarchy, but we still store all the data at level 0 and there's no double counting. So if somebody made a plan, if somebody updates a plan within a hierarchy and somebody else updated it over here, there won't be any double counting. If somebody did detailed plans and then somebody put a plan into the total, it will adjust it to make sure everything adds up. It's a really great technique. You can read it in the back of the PowerPoint. And then there's another one about iterative calcs, which I learned from Doug Pierce, who's in the room also, on recursive calcs and looping. Since it was in the abstract, I put them in the back of the PowerPoint if you're interested. And I got 30 seconds for questions. Anything? I hope that was useful. Thank you all. Thank you very much for attending.
Can I have your card? I actually want to ask you a few questions.
Sure.
So you mentioned that, like, so accounts is always dense dimension. So I was.
Well, it doesn't have to be, but that's
Right. So, and you said, like, don't use dynamic calc. So